Alright, this video is over comparing fractions. Here you can see our artiques. Alright, so the first thing is we're going to look at what if our numerators are the same. So if you look at here, I've got different pieces of pizza. And here I've got 1/2, 1 out of 2. Here I've got 1 out of 3, 1 out of 4, 1 out of 6, 1 out of 8. What do you notice about the denominator? So as the denominator is getting bigger, 3 is bigger than 2, 4 is bigger than 3, etc. As their denominators are getting bigger, the size of the pieces gets smaller. Size of the piece gets smaller. All right, well, what about me flipping that around? So what if my denominator gets smaller? 8, 6, 4, 3, 2. As it gets smaller, my denominator, the size of the piece gets bigger. Okay, well that's interesting. So based on these two things, what can we say about that? Well, hopefully what you're noticing is the bigger denominator equals the smaller piece. If you look at, so look at, 1/2 and 1/8. Bigger denominator here, but look at the size of that piece. That piece is very small. As opposed to over here, we have a smaller denominator. It's a big old piece. It's called an inverse relationship. Okay? So let's look at it if our denominators are the same. 6, 6, 6, 6, 6, 6, 6. I've got a 1 here. I've got a 5 here. So as the numerator gets larger, the fraction gets larger. That's the same. And as our numerator gets smaller, 6 all the way down to 1, our fraction gets smaller. So it's a direct relationship between numerator and denominator here, or between numerator and the size of the pieces. All right. So let's see. Here we go. We've got 1/4 and 1/8. Are pieces the same size or different sizes? The size of the piece. Remember that. So I've got different denominators. So the size of the pieces are different. 1/8, 1/7. Size of our pieces are going to be the different. 2/3, 1/3. Sizes are going to be the same. 2/3, 2/5. Our sizes are different. 4/5, 4/7. Our sizes are different. 3/4, 2/4. They're the same. 2/5, 4/5. They're the same. 3/8, 5/8. They're the same because it's the same denominator. Same denominator, same size piece. Okay, so kind of looking over here. We've got the same numerator. Who's bigger, 5 or 7? 7's bigger, so that means it's actually the smaller fraction. Kind of thinking opposite here. Okay, same numerator. I've got 8 and 9. 9 is bigger than 8, so it is opposite of what I'm thinking. 6/8 is going to be bigger. 3/5, 3/5 and 4/5. Denominators are the same, so then I look at my numerator. 4 and 3. 4 is bigger. Okay, same denominator. Look at my numerator. Same denominator. Look at my numerator. Same numerator. Opposite idea of my denominator. 8 is bigger than 12. Or 8ths are bigger than 12ths. Same numerator. I have to look at my denominator. 15ths are bigger than 18ths. Oh, I left one out. Same numerator, and so it goes like that. All right, finally, we want to work out two problems here. Olivia and Trey were running 10Ks. Olivia had 3/5, Trey had 2/3. Which correctly describes it? So we're going to start with our EFT here. 2/3, 3/5. Let's see what we get to be the same. Same numerator, same denominator. Just looking for some to be the same. 2, 4, 6, 3, 6, 9, 3, 6, 9, 5, 10, 15. I've got 6 and 6. So therefore I'm going to compare 6/9 and 6/10. Same numerators, so I have to look at my denominators. 10 is bigger than 9, but thinking about denominators, ninths are bigger than tenths. So therefore 6/9 came from 2/3, 6/10 came from 3/5. So 2/3 is greater than 3/5, 2/3 greater than 3/5. One more example here. Roberto and Caleb are batting. Roberto is 5/8, Caleb is 7/12. Who is bigger? So 5/8, 7/12, 8, 16, 24, 5, 10, 15, 7, 24, 7, 14. So I've got 15 24ths and 14 24ths. 15 24ths is bigger than 14 24ths. 15 24ths came from 5/8. 14 24ths came from 7/12. 5/8 was Roberto. So Roberto is bigger. 5/8 is greater than 7/12. Well, that's written backwards, because 5/8 is greater than 7/12. 7/12 is less than 5/8. That is true. Alright, I took the liberty of writing down a few notes here. Feel free to copy that into your IMN, so that way you can reference it later.